Good afternoon, ladies and gents, I'm Dr. Ivan, and in this video I will explain to you how to set up autonomous time-lapse photography. First, let me explain what I mean by that. Time-lapse photography entails taking sequential shots of a changing object, for example a withering leaf. Autonomous refers, on the other hand, to the fact that it should function completely on its own, taking timely pictures, not being bogged down by any computer equipment or being plugged into a power socket. Now you may object to the latter. Why on earth would anyone want to deal with such a setup when you can simply use your computer? Well, you're of course entirely correct. You could use a computer. The way that works is that you plug your camera via a USB cable into your machine and basically set whatever software that came with the camera on auto shoot with a given interval. On Linux you can use Gphoto 2 and a rather simplistic script to pull this off. The setup I am going to demonstrate in this video, on the other hand, can be used when you're not physically around your camera and do not want to or cannot use external power sources. Consider the following situation. You have a time-lapse shoot that requires several months to complete and you plan to take 2 pictures every day. So far so good, but suddenly you're summoned to a conference abroad. Even more annoyingly, you know for a fact that your apartment is going to be without electricity for at least some of the time you're out of the country. In this case, such a setup would mean the difference of having a gaping hole in your recording and it being completely flawless. This happened to me recently, and here is how I solved it. First, a few remarks. Of course you can go to eBay and buy yourself an intervalometer for your particular camera. It will probably set you back around 20 bucks, but hey, where's the fun in that, right? For this build you will need a cable with 2.5mm stereo TRS connector, often referred to as the micro audio jack. These are not common nowadays, since the 3.5mm version is far more popular and is used in almost all consumer level audio equipment. You can get these from an old hands-free set or eBay. Furthermore, you will need an Arduino or any other microcontroller of your choice, a couple of photoresistors like these, a couple of 330k ohm resistors, and 2 LEDs. Lastly, you will need some wire, preferably solid core, and at least one 9-volt battery. Provided you already have an Arduino, this setup will cost you less than $5. And now it's time for some theory. How does my setup work? To understand it better, let's take a look at this simple schematic. The camera on the left is connected to a remote cable which has the male connectors on both sides. Each of the 3 isolated areas on the connector serves a purpose. Area closest to the cable is ground. The middle and the tip portion of this connector are the positive terminals. If you short the area in the middle to the ground, you force your camera to turn on and focus. While doing this with the tip causes your DSLR to snap a photo. Our task is thus to use an external circuit to first wake the camera up and focus, and then take a photo. What this basically boils down to is that we in principle have 2 isolated circuits and one of them has to control the other. Now there are several ways we can attempt to solve this problem. Let me go through the possible solutions and then present you with the one I chose. The obvious answer is using transistors, but then we have to create a common ground for both the camera and the Arduino. This is at least theoretically possible, but involves hacking the camera battery, which is neither trivial nor recommended. Another interesting way I have thought of doing this is to use a reed switch. A reed switch is basically much like a button, but instead of touch it relies on an external magnetic field to short the circuit. In resting position the circuit is broken, but apply an external magnetic field and it will close, allowing the electrons to flow. This seems to be a rather elegant way of solving the problem with the isolated circuits, especially since we can easily make an electrical magnet with coils of wire and an iron core. During my testing, however, I found out that to make the magnet powerful enough to trigger the reed switch required rather substantial amounts of current, something that we would rather like to avoid since our setup is running only on batteries. Alternatively, you could perhaps find a more sensitive reed switch than what I used. The last alternative, and probably the one that is most commonly used, is called optocoupling, which uses an LED in the controller circuit to influence electron flow through a light-sensitive transistor in the other circuit. You can easily get an optocoupler for $1 or $2 on eBay. Unfortunately, in the nick of time I did not have an optocoupler at my disposal, so I thought I'd make something similar. The principle remains basically the same, But in my case, instead of a light-responsive NPN transistor, I used photoresistors. These are very common and rather handy due to their ability to change their resistance value based on the amount of light directed at them. If you connect them to the remote cable as shown in this schematic, you can use an LED controlled by an Arduino to change their resistance values remotely. This causes the circuit to fluctuate for a split second, forcing the camera to either turn on and focus or take a shot, depending on which of the photoresistors you illuminate. This, of course, requires that you isolate your setup from light, which is easily done with some black thick cardboard folded as small pockets. So this is the basic principle of how my setup works. Now let me show you how it looks in real life. So here we are. For my time-lapse I used a Canon 400D DSLR. This is a rather commonly available mid-range camera. It is mounted on a simple tripod and is currently in sleep mode. The on-off switch is in the on position, however the power LED is not lit. The camera itself is pointing at the object I am shooting, namely a cute little lemon on a small bonsai lemon tree. The camera is controlled through this wire cable, which runs all the way over here, and is somewhat amateurishly connected to an Arduino, which in turn is powered by several 9-volt batteries in parallel. Now, what happens here is that Arduino acts as a timer and triggers my camera to take a photo every 4 hours. Here you have the two light-isolated photoresistors together with their respective LEDs inside the two black cardboard pockets. The very nice thing about this setup is that the Arduino draws very little power and the camera itself is off between the photographs. This enables the setup to last several weeks without having to charge either of the batteries. Remember, however, to turn on the auto power off feature on your Canon and set it to the lowest timeout. I set mine to 30 seconds so that it would turn itself off almost immediately after every picture was taken. You can also turn the LCD display off, since you will not be using it anyway, to squeeze even more battery time out of your camera. So, this is pretty much it. Hope you have enjoyed this short demonstration, and if you are interested in more information, head on over to my website, to which I will link to in the description below this video. There you will find some more pictures of the setup, schematics, and the source code for the Arduino. So again, thank you very much for watching. Until next time, take care.